All right, so as we get into lesson 8.6, that's the area of composite shapes. That means we're going to take all of these geometric shapes that we've looked at the area for and figure out what kind of shapes we have in our overall composite shape, find their areas, put them together. Now, we're only going to work through a couple problems, but there are a lot of steps to this, so I want you to be able to follow along and just take your time going step by step in your notes. Then I'm going to give you two practice problems that I want you to try, and then I'll just give you the answers on the board. I want you to make sure that you can get to the correct answers. And if you can't, then I will need to help you so we can figure it out, because in our next lesson, we're going to take this a step further. As we get into it, then we see our overall goal of what we want to do. Our objective is to take those composite shapes, decompose them, break them down into their individual shapes. So these composite shapes can be 2, 3, 4 different shapes all put together. Or sometimes we may get a shape and we're going to take a piece out. So we have to be able to calculate the area. So let's review our formula. So in your book, you see this image where you can review the different formulas for the area of a triangle. I'm going to give you a handout to where you can have the formulas that we're going to be using on this assignment. There is an additional one that the book's not showing you that I want to share with you. But when we start at the top, we can see that that's a quadrilateral because it's four-sided, and it's a parallelogram, which tells us that opposite sides are parallel. So this particular case, it's a rhombus, but we could use a rectangle or a square. And all three of them we're going to find as parallelograms, which is base times height. Notice that we have the right angle. So we're going to use the two measurements that make up the right angle. That will always be my base and height. I will never use that diagonal. In my triangle, if I flip that on one of the edges, I'm going to get also a parallelogram. So I started out in the same way doing base times height, but then I simply divide it by 2 because a triangle is always half of a parallelogram. Then we have a quadrilateral where there only has one set of parallel sides, and that we said is a trapezoid. In other parts of the world, they call it a trapezium, but we call it a trapezoid. And once again, I don't like using the base 1 and base 2 because it does seem to confuse students. So I just simply change it to a plus b. So I know I have base a plus base b divided by 2. But if you're fine doing base 1 and base 2 added together, divided by 2, then that's fine. But once I do that math, then I simply multiply it by the height, once again indicated by the right angle. And then finally, we reviewed circles. And when I find circles area, then I'm going to take pi r squared. Once again, 3.14159 times my radius squared. And radius squared is not radius times 2. It's whatever the measurement of the radius is multiplied by itself. Now, the one that we add then is that we could have a semicircle, which means half of a circle. So I go through the same process and I take pi r squared, but then I simply have to divide it by 2. All right, so look at these as you're going through your assignments, as we go through the practice, and then you are going through the two that I give you that I would like you to try here in class. With those formulas in, I can then go forward in the lesson with the composite shape. So once again, they want us to decompose or to break into its different shapes. When I look at this shape at the bottom of the page, then I should be able to see that there are two different shapes. Now, sometimes they're going to give us the dotted line to indicate the division area for the different shapes. And sometimes they'll just give it to us and we won't be able to tell. We have to be able to divide it or decompose it ourselves. So as I do that then, and it gives me my division, then I should be able to see that my bottom shape is indeed a parallelogram. It's a rectangle. It is a quadrilateral with opposite sides that are parallel to one another, and it does have 90-degree angles. However, we always use the same formula if it's a quadrilateral that is a parallelogram. Therefore, it has opposite sides that are parallel. So I know that in that bottom shape, I'm just going to use base times height. But when I look at the top shape, I only have one set of sides that are parallel. The top and bottom are parallel using that dotted line, the top of the rectangle, as the base of the trapezoid. Opposite sides, therefore, are not parallel, so we see that slanted side. And so I'm going to use my formula for a trapezoid. Area for a trapezoid, once again, is base A plus base B divided by 2, then multiplied by the height. Once I solve for those, then I just simply add the area of the trapezoid and the area of the parallelogram to get the overall area of the composite shape. All right, so I'm going to be working on the next two problems with you slowly through class. This is a video that you can go back and watch and listen, but I will go quicker than we do in class. So as I read the scenario that they've set up for me, it says Ayana is painting a sign made from a piece of reclaimed wood with the dimensions shown. Ask what the area of the sign is. And it says, step 1, decompose a figure into smaller figures. So we already have that division line going up and down to show us that we have two different shapes. So then my first step has to be, if I can see my different shapes, figure out which formulas I have to use. So I should have given you a half sheet with formulas on it. And if you keep that in your math book, in your math folder, wherever you can find it, then doing these should be a little bit easier. So when I first look at it, I see a parallelogram. It is a rectangle, but I still use my formula for a parallelogram. So the area of a parallelogram is base times height. And then when I see my second shape, I see a triangle because it's a three-sided shape. Then if I know that the area of a triangle is base times height divided by 2, I have my two formulas that I need for these two shapes. Now we can get into more difficult composite shapes, where we have to do 2, 3, 4 different shapes, or as you'll see on the second video, where we can subtract or take this information and go a step further, where we are going to find how much it costs if I'm covering an area with a certain material. So when I go to solve these then, I'm going to start with just one shape. So I'm going to use my formula for area of a parallelogram, and I'm going to use my base times my height. In this case, my base of my parallelogram is 14.5 inches, and I'm going to multiply it by the height, and the height, once again, is indicated by a right angle. I can see that it's a rectangle because all four sides are right angles. Therefore, my height has to be the 4. So I plug that into my formula. Once again, if I write out my formula and then I write out my equation on my paper like I did on my slide, then I know exactly what I'm plugging in and what I'm using. And then when I go to multiply, I need to stack them because we don't multiply straight across when we have things like decimals, because it gets a little bit more complicated. So I'm going to multiply 14.5 by 4, and 4 times 5 is 20. Put down my 0, carry my addition of 2. 4 times 4 is 16, plus 2 is 18. Put down my 8, carry my addition of 1. And then 4 times 1 is 4, plus 1 is 5. Now, when I multiply the decimal by a whole number, I still have to count my decimal spaces, and there's 1. So I move my decimal point from right to left 1 time. That tells me that my area of my parallelogram is 58 square inches. Okay, so now, once again, as I'm going through these, I am going to be going a little fast. So if you need to pause it, review it, watch it again, please do so at any point as you go through this PowerPoint. Once I know my area of my parallelogram, now I have to look at what I'm going to use for my triangle. And when I look at my triangle, I need, once again, my base times my height, but since it's half of a parallelogram, I then divide it by 2. Now, when I see that I have the measurement to the left of the rectangle, then I know its right side has to be the same measurement. And that's the measurement we're using for the base of our triangle. So I know that's 4 inches. But then I have to figure out what my height is. So I have my formula, and I begin to fill it in that the area of a triangle is equal to 4 times something for the height, but that will all be divided by 2. So when I'm looking at the height, I don't know what that is. Therefore, I have to do some calculations. If I look at the top of the composite shape, I can see that from the far left to the far right, it's 20.75. The rectangle piece at the bottom is 14.5. So I have to subtract those two in order to find what the height measurement's going to be for my triangle. So when I take 20.75 and I minus 14.5, once again, I stack my decimal points in order to subtract them, making sure my decimals are lined up. And then my first step is always to bring down my decimal and fill in with zeros. Then I can subtract. 5 minus nothing is 5. 7 minus 5 is 2. I can't take 4 from 0, so I have to borrow, and 2 becomes 1 and 0 becomes 10. Now I can do that. 10 minus 4 is 6, and then 1 minus nothing is just 1. So we found that our height of our triangle is 6.25. So I have 4 times 6.25 divided by 2. So now I have to do my numerator first. So I'm going to take 6.25, multiply by 4. Once again, I like to put my larger numbers, or the ones that has the most digits, on top. I multiply by 4. 4 times 5 is 20. Put down my 0, carry my addition of 2. And 4 times 2 is 8, plus 2 is 10. Put down my 0, carry my addition of 1. And then 6 times 4 is 24, plus 1 is 25. Now I multiply the decimal, so I count my decimal spaces. There are 2 of them. So I'm going to move from right to left 2 times and put my decimal point. So what we're saying is that my numerator is 25, but I still have to divide it by 2, because if all I do is base times height, then I'm going to find the area of a parallelogram. Triangles are always half of a parallelogram. So I take my 25 and I divide it by 2. Once again, any fraction is division. The top number always goes inside the division box. I divide 25 by 2. 2 goes into 2 one time, which is 2. I have nothing left over, so I bring down my 5. 2 goes into 5 2 times, because 2 times 2 is 4, and I get 1 left over. Now I want to add a decimal, since I'm dealing with decimals anyway, and bring it up, and then I'm going to bring down a 0. And 2 goes into 10 5 times. So the area of the triangle is, so now we look at what we have. So I know that the area of my parallelogram is 58 square inches. Then I found that my area of my triangle is 12.5 or 12.5 square inches. So if I want to find the overall composites area, I have to add those together. But since I have a decimal for my triangle, I need to make my 58 a decimal. So my decimal point always goes at the end of my number, my whole number, and then I add a 0. Now I can line up my decimals, and then I can just add. I bring down my decimal, and then add from right to left. 0 and 5 is 5. 8 and 2 is 10. Carry my addition of 1. And then 5 and 1 1 is 7. So we're finding that the overall composite area is 70.5, don't forget your label, of square inches. All right, so if you followed along in class, then hopefully you have all of those steps written down on your paper, because you're going to see problems like this on your assignment. Let's check out the second one. So on this one, we're going to, take things a little bit further because we have more math to do. It says find the area of the figure and use 3.14 for pi. So when I see that I have that semicircle, if they don't tell me to use 3.14, then I have to use 3.14159. So if I get to use 3.14, they're making your life a little bit easier. And then when I get to my answer, it says to round to the nearest hundredth if it's necessary. And I'm going to tell you in this case, it's going to be necessary. I have cubed my question, and now I want to look at my composite shape, decompose it if it's not already decomposed for me, and then figure out which formulas to use. It is already decomposed for us. We have the dotted line, so hopefully we can see that we have a rectangle, which we call a parallelogram, and we have a semicircle. Right? So if I use my formula for my parallelogram, we know that that is base times height. So in that bottom portion of the composite shape, I'm going to do base times height. And then for my semicircle, then I can remember that in our previous lessons, we reviewed what the formulas for circles are. So to use my semicircle, then I have to do my pi r squared. However, since it's half of a circle, then I'm going to take pi r squared and divide it by 2. If I was just finding the area of a circle, which you'll see in the next video, then we simply use pi r squared. So now I got to plug in my information. So when I see that I'm looking for the area of a parallelogram, then I need my 2 measurements. I need a base and I need a height. Well, they give me my 2 measurements, and it doesn't matter which one you call your base and which one you call your height. They're both indicated by the right angle. So we're just going to say that the 2.25 is our base. And I do see my right angle connecting those 2 sides, so we're going to call the 1.5 our height. Now that might mean that for some of you, you turn your paper sideways and you can see that the 1.5 is the height, but either way, we're going to use both of those measurements. Once again, I'm multiplying and it's definitely decimals and therefore I need to stack them. However, Remember, because some of you are kind of messing this up, you're adding zeros in to line up your decimals to multiply. Don't do that. That just gives you more work to do. The only time I line up my decimals is when I'm going to add and subtract, and that's why we say we line them up and then bring it straight down. Then I add or subtract. So in multiplication, I just put my numbers down with the decimals where they belong, and then we deal with the decimals after we do the math. So now that they're stacked, we're going to multiply. So I'm going to start with my bottom right. Once again, 5 times 5 is 25. Put down my 5, carry my addition of 2. 5 times 2 is 10, plus 2 is 12. Put down my 2, carry my addition of 1. And then 5 times 2 once again is 10, plus 1 this time is 11. My second number tells me to bring down 1 0. And then when I'm multiplying by 1, all I have to do is write those digits down, making sure that they stay in the correct columns. So I'm going to put down my 5 underneath the 2, a 2 underneath the 1, and another 2 underneath the 1. Notice in the top part of my multiplication problem, it's 225, and that's all I wrote down was 225. Now, since they're all stacked, I can add them, both products added together. So I have 5 and 0 is 5, 5 and 2 is 7, 2 and 1 is 3, and 2 and 1 again is 3. I count my decimal spaces in my math problem. Once again, we count spaces, not decimal points, because there are 3 spaces in my math problem. So I have to move my decimal from right to left 3 times. So we're finding that the area of the parallelogram is 3.375 square feet, or 375 thousandths square feet. Once I know what that area is, now I have to work with my semicircle. And this is the one that's going to be a lot longer, as you see as I work through this in class with you. But once again, I'm going to go quicker, so you can pause the video at any time that you need to. First thing I need to do is be able to figure out the information that I need to use in order to do pi r squared divided by 2. When I see that my information that's given is 3.14 in the question, that's what I'm going to use for pi. Then I start my formula writing out the information that I know automatically. I automatically know that area of a semicircle is equal to pi, which is 3.14, times my r squared divided by 2. Now I have to figure out what my r is. Notice in this shape that it doesn't give me the radius. It gives me the diameter. Well, if you took your notes and paid attention in our previous videos when we reviewed circles, then you'll remember, hopefully, that I can find the radius if I take my diameter and simply divide it by 2. In the same way, if I have a radius and I need to find a diameter, then I just do it in reverse, and I take 2 times my radius. So in this case, I have my diameter, I need to find my radius, I'm going to take my diameter and divide it by 2. So that has to be my first step before I continue on finding the area of my semicircle. I have 1.5, which is my diameter, divided by the 2. I have to raise my decimal first, and then I can divide. 2 won't go into 1. If you want to put your 0 to hold that place value, by all means do. But 2 will go into 15 7 times. 7 times 2 is 14, with the remainder of 1. Since it's a decimal, I keep adding zeros until I don't have a remainder. So I add a 0 and bring it down, and 2 goes into 10 5 times. So what we're saying is that my radius is equal to 75 hundredths. So now I go back to my formula. I rewrite my equation using the 75 hundredths in the equation. So the area of my semicircle is 3.14 times 75 hundredths squared divided by 2. Once again, that 75 hundredths squared tells me to multiply 0.75 by itself 2 times. Some of you are still wanting to just multiply by 2, and that is not what exponents tell us. So I'm going to take 0.75 times 0.75. Once again, I need to stack those. So I have 5 times 5, 25. Put down my 5, carry my addition of 2. 5 times 7 is 35, plus 2 is 37. My second number tells me to bring down a 0, and I multiply now by my 7. So now 7 times 5 is 35. Put down my 5, carry my addition of 3. And then 7 times 7 is 49, plus 3 is 52. Then I add those together. I have a 5, 7, and 5 is 12. Put down my 2, carry my 1. 3 plus 2 plus 1 is 6. And then I have my 5. In this multiplication problem, we have 4 zeros, which tells me, or excuse me, 4 decimal positions. So I have to move from right to left 4 times. So now all we have found is what my radius squared is. My math is still not done, right? There's a lot of steps to this. So now I go on. Now, when I see it, I plug in my new equation. I write it down on my paper so I know exactly what my steps are. Now we have that 3.14 times 0.5625, 5,625 10,000ths, all divided by 2. So order of operations tells me I have to do my multiplication on top before I can do any division. Now we're going to stack those. Once again, I like to put the ones, not necessarily the most value, but the bigger number that has the most digits on top. So I have 5625 on top and 314 on bottom. I ignore my decimals until I solve for my math. So I have 3 numbers that I have to multiply here. 4 times 5 is 20. Put down my 0, carry my addition of 2. 4 times 2 is 8 plus 2 is 10. Put down my 0, carry my addition of 1. 4 times 6 is 24 plus 1 is 25. Put down my 5, carry my addition of 2. And then 4 times 5 is 20 plus 2 is 22. Now I want to pause here because I had somebody ask me last week why it is I leave these spaces when I'm showing the work on my PowerPoints. It's because I know that I'm going to probably have to carry when I'm adding my different columns after I find my products. So I just leave a little extra space. I'd always suggest that for you as you're writing out your steps with your handwriting is don't put it directly underneath your multiplication line and leave some space, because that way when you're carrying over, you can show it, because some of you don't have that space, you don't carry over, and then when you go to add your columns to your products, you forget. So going on. So my second number tells me to bring down a 0. Now I'm multiplying by 1. Right? So all I have to do is make sure that I have 5, 6, 2, 5 in that order lined up in my columns. So I just write down my 5, 2, 6, 5, going from right to left, making sure it lines up with each of the columns for the multiplication that I did up above. Now I can multiply by my 3. And my third number tells me now to bring down 2 zeros. And multiplying by 3, I go from the 3 all the way to the top far right to the 5. 3 times 5 is 15. Put down my 5, carry my addition of 1. 3 times 2 is 6 plus 1 is 7. 3 times 6 is 18. Put down my 8, carry my addition of 1. And then 3 times 5 is 15 plus 1 is 16. Now I have all 3 products for my multiplication, and now I'm going to add. So my far right, I have zeros, and then 0 and a 5 is 5. Now you're going to see why I leave this extra space. So I have 5 and 5 is 10 plus 2 is 12. I put down my 2, carry my addition of 1. 7 and 6 is 13. 13 plus 3 is going to be 16. Put down my 6, carry my addition of 1. 8 and 2 is 10, plus the 5 and 1 gives me 16. Carry my addition of 1. And 6 plus 1 is 7. And I keep my 1. Now, how many decimal spaces did I have in that math problem? Well, there are 1, 2, 3, 4, 5, 6 of them. All right, so now I got to move from right to left 6 times. Once I do that, remember when I write out the answer, if it would happen to be this, then I just drop off that 0. So you'll see that I put that in my numerator without the 0 because we don't have zeros at the end of our decimal numbers. But all I have found so far is the answer to my numerator. You're right, I'm still not done. I have to take 1.76625 divided by 2. All right, so in my fractions, once again, my numerator goes inside my division box. Notice I'm shrinking everything to get it out of my way because I ran out of space on my PowerPoint slide. All right, I've got my numerator inside my division box. I'm dividing by 2. It's a decimal inside. I can divide decimals by whole numbers. My first step is always bring up my decimal. Then when I divide, I just go step by step. Anything that comes down has to have something go up and hold that place value. 1 can't be divided by 2. If you put a 0 in front of your decimal, it's not going to be counted wrong. I just don't do it because it's not mathematically sound. But if it works for you, please do it. So then I'm asking, if 2 won't go into 1, how many times will 2 go into 17? And 2 will go into 17 8 times, because 8 times 2 is 16 with 1 as my remainder. I bring down my 6. 2 goes into 16 8 times, because once again, 2 times 8 is 16. I don't have a remainder, so I bring down my next digit, which is a 6. And 2 goes into 6 3 times. Well, that's 6, so I don't have a remainder. I bring down my 2. 2 goes into 2 one time. 1 times 2 is 2. Now, as you're doing these, if you want to put a 0 just to show that you have a 0 left over, that is fine. There's nothing wrong with that. I'm just not doing it to kind of hopefully save a little bit of time. Then I bring down my 5, and 2 goes into 5 2 times, but that still gives me a remainder. So now I add a 0 and bring it down. Now, if you had a 0 that you left from when we added our products in our 3-step multiplication, then you wouldn't have had to add a 0 here because it's already there. However, we took it off, so we added 1. And 2 goes into 10 5 times. All right, now we found the area of our semicircle. So now we have to add those together because we're finding the area of a composite shape. Once again, I have to stack them according to decimals when All right, so now I have the area of my parallelogram and I have the area of my semicircle. And we said it's a composite shape and I want the area of the entire part of the shape. So now I have to add them together. So when I add those together, I want to look at the answers that I have. Hopefully I notice that the area of my parallelogram has a whole number with it. And so I prefer to stack that on top. Do you have to when you add? No, because as we said in the associative property, I can add or I can multiply in any order and it won't change my answer. I just find it easier to have the whole numbers on top. So when I do that, I'm going to write my area for my parallelogram. And then when I add decimals, once again, I stack them according to the decimals. I make sure my place value for my semicircle are underneath the place values of the parallelogram. And then I bring down my decimal. And then, because I have 3 extra digits out there on the area of the semicircle, just hanging out, I like to fill in with those zeros. 0 and 5 is 5, 0 and 2 is 2, and 0 and 1 is 1. Those were easy. 5 and 3, that's 8. 8 and 7 is 15. I put down my 5 and carry my addition of 1. And then 8 and 1 is 9 plus 3 is 12. Put down my 2, carry my addition of 1. And 3 plus 1 is 4. Now we have found the area of our composite shape. But I have to look at what the directions tell me. The directions tell me round if it's necessary to the nearest hundredth, and it's necessary. So before we give an answer, we have to look back at what we were asked to do in the question. That is to, once we get an answer, to then round to the nearest hundredth if necessary. So we need to review place value because there are some people still struggling. I have some people saying that there's a once. There's no such thing as once. There's a ones going from the decimal point to the left. Once I go to the right, then I follow the same pattern starting at the tenths. So I have tenths, hundredths, thousandths, 10,000s, 100,000s, millions, so on and so forth. But I'll give you what I hope will be an easier way to remember at least your first 2 decimal positions. When I'm thinking about place value and I think about money, think about 10 cents and how you would write that in dollar form, right? So 10 cents in dollar form has the dollar sign, decimal point, and then a 10. The reason I ask you to think about that, because if you think about money and we think about how we break up our money, and there's no one going to be able to accuse me of forging money, but for every dollar, I have 10 dimes, right? So a dime, 10 cents, is written as 0.10. Therefore, that 0.1, that first decimal position, is the value of the dime. It is set as tenths. When I go with the same thinking when it comes to pennies, if you think about how we write 1 cent in dollar form, that is a dollar sign 0.01, right? Because for every dollar, there's 100 pennies. And the word cent actually means 100 in the Latin language. And that's where we get our idea that we have a century, which is 100 years. So if I can remember that a penny will show me the hundredths position because there's 100 pennies in a dollar, then I hopefully will remember that my second decimal position is my hundredths. And that's what we have to focus on when it comes to this answer. Round to the nearest hundredth if necessary, and it is. So I have to look at my second decimal position. And once again, my steps are that I underline the decimal position I'm talking about, and I circle the indicator. And once again, the indicator will always be to the right and nowhere else other than to the right. My indicator, when I circle it, it reminds me that it's going to become a 0, or if it's a decimal number, then it's going to drop off. But it tells me also the math that I do when it comes to rounding. So if you're struggling, once again, to remember what the rounding rules are, I strongly advise you write them down, because when you write things and you have a visual for them, it's more likely that you're going to remember them, because you're going to have to be able to do this on your standardized test, and you're going to have to be able to do it when you go into 7th grade. So when I look at my rules for rounding, then I know 0 through 4 stays the same. And if you don't remember what those means, that's 0, 1, 2, 3, and 4. Then my place value will stay the same. Everything in front of it would then stay the same. Everything behind it would become zeros, or if it's a decimal in this case, they just simply drop off. If the number that I circle, my indicator, is 5 through 9, and once again, those are 5, 6, 7, 8, 9, then it tells me I'm going to round up. So my place value will go up by 1, and everything in front of it will stay the same, and then everything behind it will drop off if it's a decimal in this case. If it was a whole number, then they would just simply become zeros. So that tells me that my 8, I have to change my 5 into a 6. Everything in front of it would stay the same. So I end up with my area for my composite shape is 4.26. Then I always have to remember that I have a label that's given in the problem, and it has to be squared because I found area. So my label is feet, it has to be square feet, and that's a lot of work to get to my answer. So hopefully this video will help you review it, and you can look at it as many times as you need to. And then I now have 2 questions that I want you to do that will lead us into part 2 of lesson 8.6.